This is me, and these are some of the things that I like to do. Number one is, as Ben mentioned, Our Ladies. I organize Our Ladies DC, which is part of Our Ladies, the global organization, and I have the Washington DC chapter to maintain. I'm also the unofficial official cloud expert for Our Ladies Global, and I do cloud stuff for them. I write for Our OpenSci. I publish a monthly blog series called .R Profile, where I get to talk to some really cool people in the R community and ask them questions about how their career has developed over time and personal questions, and then I publish them on Our OpenSci. And I'm also a course developer for Business Science University. So all of that in my spare time. I don't do a lot of non-R related things, but I really enjoy working with R, and today I want to talk to you about the cool stuff you can do in R. So my goal for this talk is for you to leave here, go back to work or school or whatever it is that you do, and sit down on Monday or Friday or whenever it is that you get back and not be able to do it because you're so excited about building data products. You're just going to ignore everything else in your life to go, and the first thing you do after this conference is build a cool data product. And we'll talk about what data products are a little bit later, but I wanted to quickly start off with some of my motivation for this talk. So in organizing Our Ladies events, I often have to field questions that I'm not qualified to answer. Questions like, how do I get a job as a data scientist or an analyst, or any job at all, anything? Or what should I study or learn or do, produce to become a data scientist? Or am I even a data scientist? Like, is what I do data science? I don't know. And so to kind of wrap my head around what I want to do to help these people out, to answer these questions for myself, is to help them develop the skill sets and tools to start producing a portfolio of their own, to start building data products and using them to validate what they do and to communicate with other people. I use these data products to communicate with people who are bad at listening or when I'm bad at speaking, and it's really empowering and has worked out really well in furthering my career as a data scientist. I also am motivated by traumatic experiences in my life. This is a visual representation of one horrible internship that I had one summer as an undergrad, where I was given a bioinformatics data set, and the professor didn't really have a plan and sort of said, there might be a project in here, why don't you take it and see? And then he went on vacation. And I spent the first whole week of this internship walking from these various labs, computer labs that had Windows machines and Linux machines and Macs, just completely petrified and paralyzed and unable to decide which operating system I wanted to even use. Because my education to that point had been so siloed. Like, I had some computer science experience, I had some statistics experience, I had some biology experience, but I didn't know how to connect those things to build something or even to start exploratory data science on a project that I didn't know even if there was a project in this data. So I've spent a lot of years since then trying to develop my skills in being able to knit technologies together and create a framework that I can use to be able to tackle types of projects where I don't know where to start. And so I wanted to go over some case studies in doing sort of that, in being comfortable in the space between data science and DevOps, being able to take a problem all the way through to production, or to build something that then you can go and show to other people, or to give, or something that works in the real world. So this was last week, was International Women's Day, hooray, and I had the pleasure of helping some other Our Ladies put an idea they had into production, where they wanted to create a Twitter bot that would tweet out every single woman in our global speaker directory. A profile showing their picture and what they do, and then a little cool sentence about them, like, read more about this amazing Our Lady. And so what I ended up doing was I used GitHub to collaborate with these other women who had written some R code. I used Docker, linked to a local volume on my machine, and then some Twitter applications, plural, because they kept taking us down. But it was a really cool project, and it worked out well, and you can go to, Our Ladies _IWD 2018 to see the results of every single Our Lady in our speaker directory. This is a project that I got to work on last summer, where I developed a course for O'Reilly on the Sparkly R package. And I wanted to be able to connect RStudio on my local machine to an Apache Spark cluster that I provisioned myself in the cloud. So to do that, I used a technology called Ansible to provision a ephemeral Apache Spark cluster, which then had a REST service for Spark called Apache Livy installed on it. And I used the Sparkly R package to initiate a connection between Livy and the Spark cluster and RStudio on my local machine. So that was really cool. In my previous job at B23, I would often be able to interact with customers and help them deploy machine learning models in production. And to do that, I would often be helping them work in Python through Jupyter Notebooks and use a software stack called H2O, which has a really cool machine learning API that I super recommend checking out if you haven't. From then, you can use Jupyter or R and H2O to develop these machine learning models, to validate them, test them out, and once you're happy with them, package them up into Java objects, and then deploy them and create REST services to hit them with. So that's also a cool project. I even maintain my personal website using a combination of tools. So you can use RStudio and the blogdown package, Hugo site generator. You can host using a GitHub web page, it's free, or the Netlify service, which has really cool built-in continuous integration service too. So if you haven't built your own website yet, if you don't have a personal online portfolio, this is another thing that I highly recommend trying out. It's easy to do, easy to get started, especially in R. And now I want to take a little side track to discuss why I'm so into R, because you might have noticed that a lot of the projects that I work on have to do with R. Some Python too, but a lot of R. And I'm so into R because, one, it's turning into this language that's not just a open source version of SAS. Like, it's turning into something that's a real programming language that you can use for data science workflows, which is awesome. This is a data science workflow that is commonly used in R presentations directly out of the R for Data Science book by Hadley Wickham and Garrett Grolemund, who are two really awesome R educators, both employed by RStudio. Secondly, the community at large is pretty cool. The people on Twitter who use the rstats hashtag are generally, by and large, very nice people, which is surprising for Twitter. And there are also other awesome communities that focus on other parts of R, like open source and reproducible research. ROpenSci is one of those communities, which is completely amazing. They have a super cool unconference every year that I highly recommend if you ever get the chance to go. Thirdly, the female community is awesome. So I might be a little bit biased in this, but Our Ladies is very cool. We put on some awesome meetups around the world. Our Ladies Columbus has a chapter. They have 380 members that I believe as of this morning. So that needs to go up in this room. Action item. Everybody hop on Meetup, join Our Ladies Columbus, and that'll make me really happy. Like I showed in kind of my case study slides, R integrates with other tech. because people are constantly building cool packages for it. Not just people from our studio, people from all around the world, across the community, are building these really cool packages that help you integrate R with other technologies and make you feel like a powerful DevOps human. So some of the technologies are ones that I've mentioned, some are ones that I will mention, but I'll get around to that. Next, it's growing really fast in really cool ways. And so fast almost that it's hard to keep up with all the cool things people are doing with R. One way I try to keep up with it is by following this R Weekly aggregator, which is a really cool website, and they publish aggregations of blogs and visualizations and other cool stuff happening on a weekly basis, as per them. And finally, I can use it to build really cool stuff. So these are some of the packages that I use regularly to build cool things in R, and I'm going to demo 2 of them today, and I will get to that in a moment. But we need to get back to the topic, which is DataOps, allegedly. And I'm really excited to be talking about this because if you were in this room for the previous session this morning, you heard about analytics ops, which is exactly the same thing as I'm talking about here. I just call it DataOps. But it is kind of the idea that you need to bridge the gap between doing data science, doing data discovery work, and productionizing something. So there aren't a lot of people who exist in that space between those two groups of people working in your company, I guess. And if we can get you comfortable or excited about learning about these things, then we'll go a long way into bridging that gap and to making everybody feel more productive and be more productive in getting their analyses out into the real world. So this is a definition of DataOps DevOps rather, that I found on the Amazon Web Services DevOps blog. And it is a combination of cultural philosophies, practices, and tools that increases an organization's ability to deliver applications and services at high velocity. What I liked about that is the deliver applications and services at high velocity portion. So here's our data science workflow diagram again. And my initial instinct is that that sentence means being able to do that last piece, communicate effectively. In other words, be able to host your analysis, share, publish, collaborate, prove point, serve a purpose, be reproducible, save the day, do all that, and not freak out about it. So DataOps to me is anywhere in this data science workflow where you can put a little DevOps magic. And once you start considering where to put DevOps in your data science workflow, you'll notice that it doesn't need to go just in the communication portion. There are opportunities to automate and make your data science workflow more robust to collaboration and to programmatic access. All of these things can benefit from the technologies and the ideas and the philosophies of DevOps. But what I want to inspire you to do is to build more data products. And in order to do that, I'm going to show off 2 technologies that are packages in R. So the first one is Shiny. And Shiny is an R package for building interactive web applications. So conceptually, it's very simple to understand. We're going to build a website that a user can interact with. Unfortunately, the learning curve for Shiny is like just a little bit hard to grab onto. But once you do, it's extremely powerful. So I recommend looking at all of the examples and really giving it a good shot before you say, no, I can't do this, throw up my hands. But I want to show you a really simple app that I built for this demo. And it involves the Iris Dataset, as most R demos do, kind of the hello world dataset of data science. And if you aren't familiar with the Iris Dataset, it's 150 observations of 3 types of irises, iris meaning the flower, and there are a couple different variables that exist for each observation. There's sepal length, sepal width, petal length, and petal width, and that's it. So the data set is those 5 variables, the 4 describing the flower, and then the 5th, which is the species. And what we're going to do with it is some machine learning because it's so hot right now. So we want to build a model that will take this iris data, and then if we give it a new iris, tell us its best guess for what that iris species is. So the first step in building a Shiny app is to turn your initial ideas into some R code. So if you can get through this step, this is the biggest part. This is the learning R step of working with Shiny. So if you can write some functions that generate the plots that you're envisioning, in this case I've used the package ggplot to do that, and then write some R code to train and validate a machine learning model to use, which is surprisingly very easy to do in R with the carrot package. There are a bunch of other packages that you could use, but I chose the carrot package. Then you can turn that code into a Shiny app. So step 1, write the code. Step 2, turn it into a Shiny app. I'm making things a little bit simplistic here, but I promise I'll show you the app. So the components of our Shiny app come in 2 parts. There's your client-side code, and this is going to be the user interface that people interact with and see. And then there's the server-side code, and that's the part that's reactive, that's listening to these client elements and saying, has something changed, has something changed, has something changed? And when it does, it regenerates everything that you ask it to produce and shows it to you on the client side again. So those are some to the basic components, and now I'm going to exit out and go into R. And I promise I'll publish all this code. It's not publicly available yet, but this is what a real-life Shiny app looks like in RStudio. And if you have a fancy version of RStudio that has this little Run App button up at the top, that's really neat. But essentially, I have it all saved in this one file. I can't find my mouse. Here it is. Okay. I've called some libraries at the top, the Shiny library and the Glue library. It's also using the ggplot2 library, but I have not put that up there. It's already loaded in my environment. And that would be a bug if I tried to send this app out into the world without declaring that, so I'll have to change that. But it has a UI block with some slider inputs. And within the slider inputs, I've decided to expose some variables. So these are the variables of the iris data, the sepal length, sepal width, petal width that I discussed earlier. And then on the main panel, I want it to show a prediction output and a plot output. My server code will output a prediction output and a iris plot output. So without getting any more nitty-gritty than that, I'm just going to go ahead and run this app and see if it works. Hey! Okay. Make it a little bigger. Cool. So this is my excellent Iris Data Explorer app. And what it does is allows you to create a new iris observation, and then it right here and here and here shows you where that observation exists in relation to all of the other iris points. And up here, it'll spit out the results of my machine learning model. So right now, the point is here, and it's saying that this species prediction is versicolor. So if we wanted to change it so that maybe it would predict Virginica, let us do that. So we've got petal width and petal length exposed here. It looks like I need to go up a little higher with length and width. And now the species prediction is Virginica. Yay! So this is a really simple app. You can do crazy awesome stuff with Shiny, and it can be deployed into production. It's fully scalable. At the latest RStudio Conf, one of my friends, Sean, showed how he could scale and load balance a Shiny app so that it could support 10,001 concurrent users at the same time, which is super awesome and super exciting. So I'm really happy about this technology, and it's super cool. So highly recommend trying out Shiny. But we have more to do, more to build. Where's my presentation? Okay. So that was Shiny. And next, I want to talk about Plumber. So, I'm running low on time, and I'll try to speed up. But Plumber is another R package for turning R functions into REST API endpoints. So you can create an API in R, just exposing your own R code as an API endpoint, which is super awesome. And it's a little bit harder to wrap your mind around what you might use this for conceptually, but conversely, the learning curve, none. Super easy. All you have to do is wrap your code in some declarations, turn your code into some functions. It's really super awesome. So we're going to build a REST API with R, and this is the process we're going to use. So we're going to write some functions in R. There are two kind of paradigms you could choose from to expose your functions. One, you could be exposing a data or a model, and that's what we'll be using, exposing the Iris data. Or you could just be exposing functions and have the user bring their data to the function. So kind of data agnostic, have them bring the data, you perform the analysis on the new data. We're going to produce some get endpoints, and then we're going to host the Plumber script on a server. Actually, we're going to do it locally, but you could do it on a server. And then we're going to send requests to the Plumber service from a different technology, which will be Python, running in a Jupyter notebook. So that's the plan. These diagrams show kind of the paradigms that we're going after. So we'll be building Plumber paradigm A, exposing data or a model, but it can also work in the reverse, bringing the data. And this is kind of my diagram of how you would build this in production. So maybe have an Ansible playbook that sets up a AWS VPC with an EC2 instance running on it, and then having RStudio on your EC2 instance, and running the Plumber API on that RStudio server, and then sending requests through your security group from those external applications. So this is surprisingly simple to build. I've done it many times, but we're not going to build that today. Today we're going to be building this, which is a Docker image, and we're going to hook it up to a local volume, which will contain a custom Docker file and our Plumber script. And then we're going to do the same thing, use an external Jupyter Notebook application to send requests to that Docker virtual machine, essentially, running Plumber, and get the result of our requests. Oop. So, again, I am running low on time, so I will just show you. This is the Plumber script, and this is all you have to add to a function to turn it into a API endpoint with the Plumber package, which is really cool. It's just like a hash tick You specify your parameters, whatever variables you want to go into your function. You specify what kind of endpoint it is. This will be a GET, and I've titled this endpoint geom_hist, and then it's going to return an image. So I've done like #tick@png to specify that that's the kind of output that you should expect from this endpoint. And then my custom Docker file is built on Jeff Allen, who developed this package, his Docker image, and I took the Docker file from that, and literally I use custom. It's not actually very custom, because the only thing that I'm doing differently here is I'm saying, hey, install this extra package. So within this Docker image, do this one extra thing, which is to install the ggplot2 package. So once I do that, I'm going to come over here and sorry, I can't make this larger. I tried already. I'm going to start Jupyter Lab in one tab, and in the other tab, I've already built this Docker. Whoop. This is my Jupyter Lab. I'll pull that down there. So I've already built the Docker image, and I'm just going to run it with that Plumber code. And this will start serving my endpoints. So now it's set up, and it's starting the server to listen on port 8000 or 8080. I have it written down here. Let me see if I can make this better. So this code is an API, and now I'm in Jupyter. I'm going to import the requests package so that I can use requests from Python, and I'm going to say get this iris plot and send the data colors equals true, and then I want to print the result of request.get. This is good. Response 200 means a success. So from ipython.display, I'm going to import image and then use image to show what our .content contains. Hooray! This is a ggplot2 image that I produced in R, and now it's in a Jupyter notebook. So I'll show my other endpoints as well. This one is the cute little geom_hist, which is faceted by species. And this one is a points facet that I'm sending petal width and petal length to. And run that one. So now I've got some awesome plots in Jupyter for all of my Python friends to use and not have to teach them how to use R. Okay, so those are my demos. I hope they were fun and impressive. But that's it. Now you're ready to go out and build some sweet data products. You know all of the things. I'm just kidding. If you liked the things that you saw that I showed, there are some awesome resources for learning R and learning these packages. The web is full of them, so highly encourage you to use those resources. Our Ladies Global Meetups, again, are a great resource for learning R. Get involved. We have the mission to recruit more female speakers, leaders, teachers, builders, and friends maybe who use R. So check out ourladies.org and follow Our Ladies Global on Twitter if you're a Twitter person. RStudio I want to give a shout out to because I use so many of their things and they produce great training content too. All of the talks from the recent RStudio conference have just been published online, and their near monthly webinar series is also super excellent. Highly recommend. There are some resources for learning Shiny development. Our studio partnered with DataCamp recently to provide a free course for building web applications with R and Shiny. So that's awesome. Also, DataCamp in general, if you haven't checked out, provides great content for learning R and Python, data science, all sorts of things. Resources for learning Plumber. This is Jeff Allen, who produced the Plumber package and who works for our studio. He has a really great documentation website, rplumber.io, and you should give him a shout out on Twitter if you're a Twitter person too, because he thinks that's awesome when people use Plumber for anything. And this final slide is a note to myself to remind me that I have Plumber stickers. So the story behind this Our Lady's Plumber sticker is that I was going to talk about Plumber at the recent Women in Statistics and Data Science conference last October, and the original Plumber sticker had a little man like hoisting a wrench up in the air on it, and I said, Jeff, I can't talk about Plumber when you have a hex sticker with this man on it. Can I make this one with a little lady on it using your graphics? And he said, yes, totally, of course, sure. Can't believe I haven't thought of that myself. So if you're interested in Plumber and you would like a Plumber hex sticker for your laptop, please come see me, because I have 50 or so. So thank you so much. I can take questions. Or not. Oh.
Thank you for your talk.
Yeah.
The examples that you showed, they are more like continuous integrations for web servers. Like this could have been implemented in pretty much any like web technology. What I'm interested in is like, from your experience, is there a DataOps practice for like continuous like model development? I come from a group where we are like manually like crunching, a classifier once a week, and then like manually staging it and like a repo, and then manually deploying it. Like it's just a real mess. So do you have like techniques for how to like deploy something where there is like a continuous like, training process with like data input, something that's more like focused on model development, not necessarily like just generic web software?
Yeah, I've been thinking about that a lot because of my work with H2O, and I don't have a good answer for you. but I know that if I'm thinking about it, other people are definitely thinking about it. It seems clearly that you're thinking about it. So, yeah, it's going to happen. We're going to figure it out, hopefully soon. But definitely that's a great question. Sorry, I don't have a better answer. Hey, cool. Yeah. Come find me if you want a Plumber sticker. And thank you.